Howdy. I'm really excited I get to follow Substack. We both live about 20 blocks from each other on the other side of the world. Come and visit sometime in Oakland. So I want to talk about the LEBRON stack, which stands for LEVELDb, BROwserify, and NPM. And LeBron James is the namesake, and I'll say why. Here's an awesome logo that Substack drew on his Wacom tablet, which is down there. You can check out the LeBron stack at lebron.technology. But really, what I really wanted, or actually, so who I am, I work on a couple projects. Node School, there's a Node School tomorrow, and we're doing a Node School tour of Norway that I'm really excited about. It's basically learn to do Node by taking Substack's brain. We put them into Node modules that you run on your command line, and then you have to solve challenges in interesting ways to pass the levels, and then you, at the end of it, you suddenly know Node. So we've had thousands of students come through it. You should check it out. And it'd be cool to get a regular Node School meetup, just like how it'd be cool to get a regular map time meetup up here. And then I also, my day job right now, I actually have a day job this time. Last year when I spoke here, I spent the year working on Voxel.js for fun. But this year I had to get a job, so I started working on a project called DAT, which is to help scientists share data with, well, basically share large data sets for research purposes. And it's all using Node and the stuff that I'm going to talk about in kind of an abstract way. But to get things started, let's get some jams on. Can I get? There we go. This is an intro to LeBron. So as you can see, LeBron outperforms every other web framework possible. There he is, getting around Angular. Oh, MongoDB, can't touch him. PHP tries to get the ball. PHP goes straight into the crowd. LeBron's where it's at. Also, thank you to whoever remixed the Final Countdown with the Space Jam soundtrack. So, LeBron James is the world's best basketball player, undoubtedly, who plays basketball in the NBA today. And also, now has the best set of technologies for combining modules into applications with JavaScript. What a coincidence. And here's all the things that LeBron supports. Not only does it support model view controller, but there's some other ones you might not have heard of. Model view model, model view view model, controller model view, and then I think that's the year 24, or wait, no, sorry. Model controller controller model view model, controller view view model queue processing, CSV format, HTML5 and HTML, also enterprise 0MQ and B2B. No, sorry, just kidding. Seriously, LeBron starts with BROwserify, and Substack wrote BROwserify. And it's basically not that exciting of a concept because it basically just brings compatibility from everything on NPM or everything that's written for Node, the module system, to work in the browser. And there wasn't a module system when BROwserify started that is in browsers. There still isn't a module system in browsers. There will be one day, and people will figure out ways to make these modules work with those modules. But if you want to use modules today, and there's a ton of modules you can use, that's basically what BROwserify is for. So the cool part is there's JavaScript all over the place, right? You have JavaScript on phones. There's like projects now like Tessel.io, which cross-compile JavaScript to Lua and then embed it as bytecode on embedded processors, so you can run Node modules without having to modify them on little tiny devices to do hardware. There's JavaScript like on the server, on the client, on every different browser. And what are the differences platform-wise? Like, this is oversimplified. Notice the star asterisk mostly. But in Node, basically what you have that you don't have in the browser is raw UDP and TCP sockets. And the HTTP in browsers sucks. Node has way better networking because it's built as a networking platform. And you have file system write access, but there's, I'll talk about that in a minute. But on the browser, you have DOM. You have a visual rendering like DOM layer. And Node is usually just processes running and doing I/O, talking to your computer. Obviously, yes, you can write Chrome extensions and get UDP in the browser, and vice versa. You can hook up a DOM to Node, but normally, for most use cases, those are the only two differences, and this isn't to scale. The green part should actually be like really big. Like if you write JavaScript, it can run anywhere. That's why I got into JavaScript. I'm a recovering Rails developer, and what I didn't like about it was that I had to write all my code twice, and I had to learn all the community things twice, and I had to learn the culture and the testing and everything twice, and I just wanted to pick one thing, and Node has enabled me to do that. Or really, I just like writing JavaScript because now it's fast enough to do everything I want to do, and it has the best libraries. And so modules are the way that you do that, and this might be too simple for people, but I want to say it anyway. A module does one thing. It's not a grab bag because that's not apparent at first, but if you have a module that has too much surface area, then people end up using your module for just one of the 10 things that it supports. That's not as optimal because we're getting into this scenario a lot more often where you have these really complex dependencies in your application. You might require a module that requires another module, who requires another module. You end up having 300 modules, which is totally fine because if they're all small, they'll still be smaller than like one copy of, say, a big library like jQuery or Angular. But you don't want to have one module appear a bunch of times in your application at different versions. So it's better to have small modules because then you only require what you need and ask authors to publish multiple modules. Publishing modules is really easy, and there's tools to automate it. And then also CI is really important. I want to see more things that are verified to work before I test them and then they fail. Like, I used to say that I wish that everyone's, the minimum should be everyone's module. I can clone it and then run the tests in like 2 commands, not have to install some custom test runner or learn some API, but just clone it and run the tests. But I'm even lazier now. I want people to run the tests for me and have a badge in their README that says that it definitely works so that I don't have to waste my time looking at their thing if it doesn't work. And as a maintainer, if it's too hard to do that, then tell other people who are better maintainers than you to write tools so that it's easier for you to write CI. We should be able to solve the problem of saying where something runs. Like if you write a JavaScript thing, you should say, here's all the platforms that it runs on, here's all the ones that it doesn't. Like this would be a really cool goal for the community. It should also be really easy to install and also easy to read the documentation in the README. Don't go overboard and work on a documentation framework until people start complaining about your simple README. So if you haven't written a module, you should set yourself a New Year's resolution or whatever the culture is in Norway for trying to get yourself to like lose weight or drink less soda or whatever, and write one module instead. I define them as natural abstractions. And so LEBRON is a framework, but it also isn't really a framework. It's a collection of a bunch of modules. And the difference between a module and a framework, I know it's not a very scientific definition, but my definition is, say a hot new technology gets released, such as Node, and everyone that writes, say, like Rails or PHP wants to switch to the hot new technology. There's this kind of race to publish the first Rails of Node. And so you have people that make up these abstractions that aren't natural. They're guesses that haven't been battle tested. And then everybody switches to that, and then it gets really popular, and then we're stuck with them for 5 years. And there's a lot of examples of this in every ecosystem. But over time, if you zoom out of the timeline and you look at the things that stick through it, the ones that people love years later and don't feel like they wasted time on, those are what I call the natural abstractions. But unfortunately, those take time. But it helps like if they're small and simple, because then they're done. And if people use them and they don't complain about them and they don't send pull requests and they don't switch to other things and they don't get confused, then you know that they're good natural abstractions and you can move on. But it takes a community a long time to build those things. But luckily, Node is getting more and more it's growing up. And there's a lot more of these natural abstractions around. The other nice thing is that because they're small and unopinionated, if you use a framework that you really like one of the features and you don't like the other 5, but you already wrote all your code to support their weird API, you're kind of locked into that. But with small things, you can swap out the subdependencies a lot more easily without having to switch off the entire giant project. So that's another huge plus. And just to reiterate this point, here's another play-by-play. So LEBRON goes in for the dunk, right in the framework's face. There's a framework that he just went around. LEBRON comes over. There's another framework. Oh, LEBRON's better jumper than that framework. And yep, framework gets knocked down. So basically, LEBRON beats out literally every other framework. We'll just go one more time. And swish. All right. So here's an example of one of these things I'm talking about. If you use like a normal database, you have like your ORM. You might have like one module that does everything, and it might have like a plugin system or something. But there's this project called LEVELDb that used to not exist 2 years ago, Google released it, I think, in 2011. Anybody running Chrome, either on Android or on desktop, raise your hands. So everyone who raises their hand has LeveldB right now. It got very popular because it got into Chrome, so it's installed like everywhere. And the cool part about it is that Google wrote it for their Bigtable project, which is like a distributed database. They had a thing called a pagelet, which is one node in the Bigtable thing, and then they rewrote that concept for Chrome as LeveldB, and they released it as a C++ library. It's kind of like SQLite. You can embed it in your program. You don't have to run a big infrastructure and deploy it on its own server and talk to it over something. The Node people picked it up because you can just require it, and it's very unopinionated, and it's a really low-level API for just storing lots of key values on disk and not have to worry about getting them. And it also works really well on SSDs, and those are getting more popular, so it's really fast. But I mean, LeveldB is just another database, but the cool part is that when you combine it with NPM, you get this really cool non-vendor lock-in. So here's 4 examples of using LeveldB. It works in the browser and it works in Node. So that's, like straight off the bat, I think that's pretty cool. For instance, if you're on a browser with IndexedDB, which is a W3C thing that's a browser API, you can use this compatibility layer, LevelJS, which provides the same LeveldB API that you get in Node, so you can run the same code in Node or in the browser. And it just works transparently on top of IndexedDB. You can also run the same LevelJS code on top of local storage or web SQL. And then on the other side, over on the server, you can run a thing called LevelDown, which is a Node native binding to the LeveldB C++ library, but it uses the same JavaScript library. So you literally run the same JavaScript API regardless of what the backend is. And LevelUp is designed to be it's also super low level. LevelDown is lower level, and LevelUp is JavaScript low level. But if you npm search for level, you'll find, I think, about 200 modules that extend the database in different ways. I was recently trying to add server-sent event support, and there's already a module for keeping track of changes in LeveldB and streaming them out. You can also use experimental backends that aren't LeveldB. So there's a database that's a fork of LeveldB by the guy that worked on HBase, which is like one of the Hadoop projects, big data thing. And he works at Facebook now, and Facebook forked it and called it RocksDB. And it's a LeveldB designed for deploying to SSD data centers, which is what Facebook uses. So if you need to throw some engineering and deployment stuff to really deploy it at scale, like you can use the backend that Facebook uses. You could also, there's some really crazy experimental ones. You could run it on top of MySQL. There's a project called MySQLDown, which translates the LeveldB key value store and streaming search API to SQL queries for compatibility reasons. So it's a really cool example because you don't have to change your JS code. Like if you wanted to switch from Mongo to MySQL, you'd be kind of screwed because you'd have to rewrite everything. And LeveldB doesn't have SQL search, but it has other types of search. So if you know you're going to be doing a certain type of search, you can write your code in LevelUp. And then if you need a different backend for some reason that has replication or snapshot support or something down the road, you're more free to move around, less vendor lock-in. And in the DApp project, we use LeveldB because we can replicate data between node processes and to browsers. Here's an example of the README for that right now. It's just one of the ones that I do CIs on. I really like AppVeyor. It's like Windows Travis. And then I also like Travis, and I also like Testling and Sauce Labs alternatively. So Dat doesn't run in browsers at the moment, but it's running in Windows and Mac. And I started making these fun little markdown tables that have all my CI things on it. And I even got so OCD about it that I sent a pull request to shields.io to add a flat design style to their badges so that it matches the AppVeyor one. And this is another badge service, node.co, node.i.co, which just basically gives you some statistics on your module that you can put in your README and gives people instructions on how to install it. And there's also tools like something called Testlingify, which you just run Testlingify on your module, and it automatically registers it with this browser testing service that Substack runs. And then you just have to put the badge in your icon, and every time you push to GitHub, it runs your tests in all browsers. I just have 3 browsers set up, but I'll show one that has more in a minute. So Buffer, for instance, this is one of the coolest modules that's like the least celebrated. Node.js.org API buffer.html is written for Node, And it assumes you can, when it was written, it assumed you were running Node, all these documentation details. It's like, obviously you're running Node if you're on the Node.js docs, because browsers don't have binary. And Node had to invent buffer, which is its way of dealing with binary data. But then typed arrays came out right at the same time. And this guy, Faraz, figured out, hey, let's take all of these APIs, every single one for reading and writing data in different binary forms, and slicing buffers and allocating new buffers, and let's just make it work everywhere. Even IE6, binary data in IE6, which should be possible unless you have a time travel machine. But the way he does it is he converts everything to hex and stores it on objects. So it's slow, but it works. That passes the test suite. So any code on NPM suddenly that ever required buffer or used buffer, which you get buffers back from everything, now you can use with BROwserify and it just works, which is pretty awesome. Some things in browsers you can't just make work. Like HTTP is fundamentally different in browsers than it is in Node because it's streaming in Node and you can't really get true streams in the browser. You can fake it to a certain extent, but browsers aren't really designed today, unless you use WebSockets or WebRTC, to stream, open up stream, duplex streams, and stream lots of stuff around. But hopefully that'll get better in the future. So buffer is this really cool compatibility layer that removes the need to rewrite your code again to work in browsers. But let's talk about some fun stuff. So nothing but nets is a module that I wrote. It's just called nets. I wrote it on the train on the way up here because for a long time I have ignored this problem of when I write HTTP code, wanting to use the same code on Node and in the browser. And like I just mentioned, HTTP is kind of better in Node. It's not as good in the browser. But I wanted to use this as an example of a module that is really simple. It's actually deceivingly simple. All it does, it has a Testing badge, and I got it to run in, basically, if my code runs in any Internet Explorer, I'm pretty happy. And you just require, this will look familiar to anybody that's used the request module in Node before, which is like one of the most popular Node modules. You just require nets, which stands for internets, but it's also part of the LEBRON framework, so it stands for a basketball net. And so you can get nets with it. Internets or basketball nets, and you basically can use all the same request stuff. There's no streaming support because streaming would kind of be a lie in the browser, but you can use this module, and if you use it with BROwserify, it'll run in all these browsers, and if you run it in Node, it'll run on Node, and it also runs on Windows. And let's take a look at the source code. Holy cow, it's 7 lines of JavaScript. How did I do that? So all it does is it requires request, which if you use it in Node, you'll get Node. Node's request module, but there's a trick, one weird trick to make HTTP work everywhere, is you have dependencies, request and XHR. And XHR is a module that has requests API, but all it does is work on top of XML HTTP requests. And the really cool part is that BROwserify automatically, where is my browser field? Oh, here we go. If you just tell it, if you're in the browser, instead of request, just use the XHR module, then when you use it in a browser, BROwserify will automatically swap them out. So this module is like a meta module that just kind of demonstrates because the request author, who's a friend of mine, that I've been trying to get him to support requests, I even said that instead of giving me a birthday present this year, he should just make request work in the browser, but he hasn't done it. I told him, hey, you should make request work in the browser. You won't do it. So instead, I just have to publish a meta module, which proves that you could write an XHR implementation of the request API and just use whichever one is the right for your environment. So there's, like, for code reuse, there's lots of tricks you can do. And also for code development, it doesn't have to be super manual. So if I mate a cat.js right now, and I go to, don't read into that too much, and I go into a new file called cat.js, and I just require the cat picture module, which is, in my opinion, some of my best work. And all it does, I mean, anything I require is going to be on NPM. So you can look up cat picture. And let's see here. All it does, it makes a cat picture appear on your website. I actually have multiple modules that do this. A side note, or actually I'll finish the demo first and then I'll show it. So you can BROwserify cat.js now, and BROwserify will be like, okay, here's all of the code that's required to render the cat.js module. But that's just JavaScript, so you have to copy it or save it to a file, put a script tag, make an HTML file. So instead, I like to do beefy cat.js, and beefy is like BROwserify as a server. So it's the name is some pun on Browserify that I forgot about. Browser and Browserify or something. I don't remember, but Beefy is for Browserify, so that every time you load this page, it'll create an index.html for you, and then it'll just run the bundle. So this is what cat picture does. And let me show you the code for cat picture, because just to show you, there's no like cats up my sleeve. So cat picture uses FS, which shouldn't exist in the browser, but somehow it works, even though I'm in a browser running an FS code, or FS code in the browser. But what I do is this trick where I take the buffer, convert it to hex, turn it into a data URI, and then set it as the attribute of an image. But how does it go from reading a file to having a hex string? There's a cool, another feature of Browserify called transforms, and you can tell it anytime you Browserify this module, run the Browserify file system swapper, which knows how to take read file sync and replace it with the actual file in line. So if you look at the output of the cat picture module, you'll see that, oops, I gotta go up. You'll see that there's this big, where there was FS read file sync before, you now have this big inline hex string, so that you can fake the file system call, and instead varcat equals my hex string of the file, and in Node it'll actually read the file system. So it's a quick hack to just use FS code that works in the browser. It doesn't work for everything. It's not streaming, obviously, because it buffers the whole string into memory, but it's good enough for my cat antics. I haven't actually tested this. I just remembered that I sent this pull request. But so if another cat picture module I wrote, if you go to npmjs.org and you do the Konami code, up, up, down, down, left, right, beat A, and then enter, your mouse cursor turns into, oh, where'd it go? Oh, there it goes. OK. Your mouse cursor turns into this cat, which is Isaac's cat. Isaac wrote npm, and I sent him a pull request to add his cat as an Easter egg cursor. So I don't really know why I showed that. Next slide. Watchify is cool, too. People ask all the time. So I have my cat file, watchifycat.js. And, oh, wait. -o cat bundle.js and verbose mode. So all this does is, everybody's seen file watcher stuff before, but instead of having to run Browserify every single time, or even instead of having to reload the page in the browser, you can just like save stuff in this file, and then it'll bundle it. And if you require stuff that doesn't exist, like foobar, baz, and save it, then you'll get a nice little error output that tells you, hey, you tried to require a thing that doesn't work. So Watchify is just like a file watcher mode for Browserify. And the really cool feature of Watchify is it's a caching bundler. So if you require a new thing, it'll only have to go and rebundle the parts underneath that module. So if you have a huge project that uses like 1 million modules and it takes 8 minutes to build, you only have to do 8. I mean, I've never heard of anybody having maybe 8 seconds is the top bound that I've heard of. But if it takes 8 seconds the first time with Watchify, it'll take like milliseconds the second time. And it gives you the time that it takes to rebundle. So the first time I ran it, 0.27 seconds, and then the second time, 0.01 seconds. So that's a really useful debugging tool. And there's lots of this stuff. And one of the problems, my biggest critique of NPM, is that I prefer it because at the end of the day, you can pick the tools that work for you, but you have to pick the tools that work for you. And we're only now getting to the point as a community of documenting what the tools that we all like are. And so that's what LEBRON really is it's a set of technologies that happens to work really well together and be really flexible for doing things that are real-time and highly modular. There's also, if you want to write tests that run in Node in the browser, there's tape, which is a really simple way of writing a test suite. You can require tape. You can say, or var test equals, and then you just do things like test foo, and then you get a function for every test, and you can say t.equal 1, 1, and 1 should be 1, and then you end the tests, and it's a pretty awesome test suite, but you can say, now my cat.js is a test, and so I have one passing test, and I can Browserify, or actually let me beefy my cat again, and so now I have a beefy server running on my tests, and what's cool about that is that you can run the exact same test suite in the browser. So it'll, oops, I had to enter. So now it runs my tests here, and I probably have some stupid bug in my tests. But you can browserify your tests, or you can run them in Node, and that's how Testling works, is it runs the browserified version of your tests. So it's like, if you're writing JavaScript, do things so that it runs on any JavaScript platform. That's what I'm trying to promote here. And a lot of people, when they write Node modules, they intend them to only work in Node. They don't even realize that you can use Node modules in the browser. That's getting more popular. So there's like little simple things like if you use FS, in certain cases we can make FS work in the browser. We're coming up with even cooler ways of doing it. I already talked about Testlingify earlier. But like Level File System is written by Matthias, and it combines Leveldb, which runs on local storage, on WebSQL, on IndexedDB, and it implements the entire Node FS API on top of Leveldb. So instead, in the browser, we don't have a file system yet. They're working on File Writer API, which is like a way to write files. But until that's there, there's no way to really save data in the browser other than in an asynchronous fashion, other than IndexedDB. But luckily, in all these browsers, you can run every single API in FS, which is awesome. So you can even do file watcher stuff. You can do directories. You can scan directory trees. There's so many like modules that now will work in the browser. But there's other crazy things like that we had to figure out. We were just talking about this the other day. Like, okay, if you can have a fake file system API, how do you get files there in the first place? And we were thinking, like, if you try to read a file called cat.jpg, in Node, it can just read the file because the file's there. But in the browser, maybe it waits for you to drop a file called cat.jpg before the code starts working. Because Node's async, so it's not going to block the web page from working. It just won't receive any data until the user drops it on the page or something like that. Or we could swap out the file system with BitTorrent or other crazy mad science things. But we're getting more and more compatibility between Node and the browser, and what's cool about that is you achieve maximum module reuse. And this guy, Jake, or he goes by Reynos on the internet, he is working on two of my favorite frameworks, which are spiritually related to LEBRON. And let me show you. He has a web-scale web framework and a HTML6 client-side framework. And let me just show you the code really quick. So what I love about HTTP framework is it takes the Express.js examples, and he shows you how to use simple Node modules to achieve the same exact things without having to require all of Express. So for instance, if you want to do cross-origin resource sharing, which is how to do cross-domain requests, here's how to use these 4 or 5 modules to, and 37 lines of code to do cross-origin resource sharing. If you wanted to do uploads, sessions, static files, validations, all the stuff you can do with any of the other web frameworks, but you want to use only the best tools for the job and not take on a bunch of technical debt. Like there's been big bugs with web frameworks in Node, and basically in general, where they have like form parsers in them that let malicious users fill up your hard drive, but people that you were using it didn't even parse forms, but it was there and turned on anyway. It's best to like minimize what you're using. So check out HTTP framework when you're building your next server-side app. And then the same guy who wrote Mercury. He's actually working on it right now. I don't know if he's announced it, but I'm going to go ahead and present it at a conference for him. But Mercury is so funny because check this out. The Mercury, this is the implementation. It's an object, a JavaScript object, with properties set to requiring modules. And I love that. It's like, this is the framework. It's just a bunch of modules that happen to work well together. And Mercury is basically his answer to React or Angular, these things that do, one of those MV things, MVVM. I don't remember which one he says this is, but it's split into 3 areas, and he's written most of these modules, but the coolest part is the rendering. You have an event system for binding reactive events to elements. Then you have an observable data structure that instead of doing JavaScript object getters and setters, you can have objects that are truly observable for all state changes, so that when you emit events or you bind to events and the state changes on the objects, that all feeds into these virtual DOM elements. So he has a way to write HTML that can be tracked and diffed and patched, and it can only update the parts of the web or the app that are changing, which is the same thing React does, except this has, in my opinion, natural abstractions, aka way better APIs. And you can always swap these things out later. if better, more performant virtual DOM things come out. So you're not locked into any of the one frameworks. And then he all ties it together with an event loop based on request animation frame. So he has some really cool benchmarks here. Like, let me show you this one, I think. There's like this really cool, oh, yeah. Oh, I need the full result. It's a really cool benchmark where you can say, let's do the same animation with, say, React.js. And it's averaging like 16.5 milliseconds per loop. And I think you need 16.6 to be 60 frames a second, 30 frames a second. And you can try out all these different frameworks and see how fast they render things. And like Backbone out of the box is like 25 milliseconds. No framework at all is like 13, 14 milliseconds. And then Mercury is about 14.5 milliseconds. And he has a bunch of really cool benchmarks like this that show that if you're doing DOM diffing, let's do a shootout and see which of these frameworks is faster for doing virtual DOM diffing. And his is the least opinionated, which I really like. So then there's the problem of build steps. So if you have modules, you can't just put them in the browser because, check this out, like, or I should probably, yeah. So in Chrome DevTools, if you say require, like foo, you'll get an error because require is not there. But there's a bunch of these module servers coming out. So for instance, this is one that I work on called BROwserify CDN. And all it is an HTTP API on top of BROwserify. And what it does is it goes to NPM and fetches things for you. It caches them, and then serves the bundles. So you can put in any module in NPM. Here's one, which is a module that does some stream stuff. This is the exact same output you would get from BROwserify. And you can take that and put that in the browser. Wait, where am I? And if you paste all that code, and then you type require, require will be there. Oh, wait, I did the wrong one. I have to do build. Substack, do you remember what it is? It's like, there's a different version instead of standalone. Bundle. I think it's bundle. Yep, OK. So then I take that and I put that in. And what that does is basically takes the output from BROwserify, which require is now defined in my browser. That's what BROwserify does. But I can also say, just like I was in Node, but I'm in a Chrome DevTools right now, I can say var cs equals require concat stream. And that'll work. And now I have the concat stream constructor, just like I was in Node. That's all the build step is. You just have to somehow compile all your modules together, or you can do them one at a time like this. So I could have taken the output of this. I could literally put this URL in a script tag, and it would work on my page as long as I put the script tag before code that uses require. So you don't necessarily have to put everything in one bundle. You don't even have to run your own build infrastructure. You can. The cool part about this stuff is you build it, and then you just put it in one bundle if you want. You can minify it, put it on a CDN. It's like really flexible. There's lots of different ways to deploy it and optimize it and remove duplicate dependencies. And then there's all these competing servers that are trying to figure out how do we get modules into the browser today that's future compatible. So check out all the options. But build steps are kind of, I think, a relic of the past that we shouldn't be depending on anymore, and we shouldn't be scared of build steps. Or sorry, non-build steps, like dynamic loading is a relic of the past, but we should be embracing build steps. Because like when HTTP 2 comes out, you'll be able to have 900 script tags on your page, and it won't really have that big of a performance impact because they'll all be multiplexed over one connection anyway, as if it was minified. So there's like a really bright future. And an example of this is a static site that I work on. It's 100% client-side, and it uses BROwserify CDN. So let me get a little bit bigger here. So all this does is there's an iframe on the right and a CodeMirror editor. Shout out to Marian, who works on CodeMirror. Thank you. On the left, and you can write stuff that assumes that require is there. So I could just delete this and say require my cat picture module, and then I just run that. And then what it will do is it'll go and BROwserify on BROwserify CDN and then run my bundle. So I don't even know BROwserify exists. I just have to require modules from NPM and use them, and then it makes them show up in the iframe. And you can share these as gists. There's some really cool ones that people have made. The default one uses some of, I think, or a canvas module somewhere. There's like, or no, request animation frame module. This is a demo of using RAF, which wraps window.requestAnimationFrame to make it work everywhere, and then just the Canvas API to make this circle do cool stuff. So the cool part about this is that it just uses BROwserify CDN, and this is all hosted on GitHub Pages, and you can save to gists, fork other people's gists, and it's just a static site that was built using BROwserify, but there's just one bundle in the HTML that it loads that's all been minified. So I really wanted to basically bring the BROwserify workflow to the web without having to use the command line, and this was my experiment in doing it, and I ended up working on BROwserify CDN as a process. But I'd love feedback on this, or I'd love to see you build cool stuff. And then there's another big initiative, which, like I mentioned earlier, finding these things is the hardest thing, which is a good problem to have. The internet got really popular for about 8 years, and then Google came along and solved the problem of finding things. And Node has been around for like 5 years, so I figure in about 3 years we'll have a Google for Node that will be able to find modules. So you have maybe 3 more years of having to find things. I don't know. That's my Ray Kurzweil guess. But we need to build a BROwserify search engine. So if you don't want to wait 3 years for somebody else to figure it out, here's what you should do. You should go to this gist on Toby Ho's gists, Airport EH. He tweeted it out, and all my slides will be online later. And read this gist. What he's basically trying to do is bulk process every module on NPM. There's 76,000. Download each and every one, all the source code, all the dependencies, run them all in Docker containers, see if the test suite passes, then try to BROwserify them, see if BROwserify crashes, then open up a browser, then see if the bundle from BROwserify runs in the browser without crashing, then if it has a test suite, try to BROwserify the test suite and get the test suite to run in the browser. Then he has a bunch of statistics, he has other things he wants to do. He wants to figure out, okay, let's just get a sample size of a subset of NPM that we think work, and let's just try to create some algorithms for testing those. If we can just automatically tell you ahead of time if a module from NPM works in the browser, then we can make a lot more people write portable JavaScript code that works everywhere. So this is a really cool initiative. If you want to help the search effort, check that out. There's also, I've basically only talked about CSS, or sorry, JavaScript, but I want to talk about CSS and HTML. The cat picture thing is an example of using BRFS, which lets you require static assets, like templates. BRFS is awesome for templates, because you can have templates that work on both sides, and it converts them so they work in the browser. There's also 3 other cool projects, which are for various approaches to writing not just JavaScript modules, but also modules that do like web components, not in the sense of Shadow DOM, but in the sense of small modules that provide UI widgets that don't overlap with each other. So check out Rework and Atomify and JS CSS Loader, and if you have an idea for how to do this better, you should write one. Also, it's a really exciting space. There's some really cool thinking going on there, but like for instance, the way that Rework works is you can have, instead of index.js, you have index.css. And then you can do things like, give me all my style sheets in one style sheet from my whole dependency tree. And it'll just recurse the same way that NPM recurses, find all the style sheets that you need from the modules that you use, and then give you one style sheet you can put in your page. And we need more things like this, because figuring out, like, none of this stuff is in Node, so that's why it hasn't happened yet, but there's some really cool stuff going on. And here's an example of how LeBron is a pro team framework. Like, there's Substack right here. He's helping LeBron out. He just blocked that guy. LeBron can get to the basket. There's LeBron dunking. And then here's what happens. Here's everyone else on LeBron's team, everyone who publishes awesome Node modules. And then everyone who npm's install stuff is in the crowd cheering on LeBron. And here, watch Substack do this awesome block right here. There we go. And there's some cool people that have made LeBron possible. LeBron isn't just the only guy. There's other people like Dominic Tarr, these guys down here who present about awesome modules, everybody else that's ever written a module. Thank you, anyone who's ever npm published or npm installed. Basically, what LeBron represents to the future of web development is not just, don't use Facebook or Google's big giant thing. It'd be cooler if Google contributed to a project that 100 other companies contributed to, or 100 other individuals contributed to. I'd like to see more of these barriers broken down so that we're not stuck using one company's platform. We actually develop modular software without vendor lock-in, So that's what I think LeBron represents. And also, he's really good at dunking. And LeBron is a slam dunk. The LeBron website proves this, lebron.technology. And we're actually endorsed by a former, oh no, my DNS is messed up. The .technology, TLD, is a new thing. Apparently doesn't work on this conference Wi-Fi, but oh well. Definitely bought it as a joke. Here's some awesome small module authors for you to check out. Many of them are here. You should talk to them before they fly back to wherever they live. And there's a bunch of other really cool stuff. Sorry if I didn't mention you on here. There's limited space. For instance, like Damon, just to shout out one random guy, it's an awesome dude in Australia that does a bunch of WebRTC module hacking. Julian is this kid from Austria, southern Germany, near Austria, who has the most deep voice I've ever heard in my life, but writes really cool client-side components. So check them out as like idols in the community to just copy and publish lots of modules too. And that's all I have. Thank you very much.
So the problem is an idea of like we have all these modules going on and making them easy to discover, or like I can go in, okay, I use these bunch of things, then I know I can do this stuff, but probably in the nature of it, you can't do everything with it, and you still need to discover new stuff, and there's other things that are like LeBron, but not LeBron. How do you find them, and how do you find the additions? And you say, okay, wait 3 more years until you have Google for NPM, but what do we do now? How do we figure out what are the good small modules? What are the things that I can depend on? What are the things that are actually working for my use case?
So I really like, I have a method for determining what a good module is, and I think that one thing I learned at a young age, I was lucky enough to grow up like while the internet was growing up. And so I learned when I was a kid to be really good at sifting through the internet and finding things. And I've heard some theories that search will be foreign to kids in the future because autocomplete will just do everything for them. And they won't ever hit the next button, like go to they'll always be in the G on the Google and never go to the O. And that actually really scares me because the coolest part of the internet is the part past the front page. Other than if it's like a cat photo site, then all the best cat photos are voted up to the top. But I really think it's valuable to be good at sifting and due diligence kind of. Maybe that's the wrong term, but basically doing your research and spending maybe half an hour searching GitHub and NPM. Those are the two places I look. So I do the NPM command line search. I just search for all the keywords I can think of. Then I do some grepping. I try to find out, if I want to do BitTorrent, that one's really easy because the word BitTorrent is pretty unique. But if I want to do like templates, oh my God, there'd be like 800 results. So sometimes if it's a really popular thing, you're just overwhelmed and you'll pick the one that you might think is the most popular. But I like to do exhaustive GitHub searches also. Search for keywords on GitHub code search and search through all the repositories until the end. I find that if I spend more time up front looking for things that maybe aren't as well findable or as popular yet, I usually can find something on NPM or on GitHub that somebody's done that does what I want. And even if it doesn't do it exactly as I want it, it at least can inspire my not invented here rewrite. And I like to give credit in my readmes to, hey, I was going to use this thing, but it wasn't quite right, but I used it as inspiration. So I would say that manual search is the best way, other than asking people. But if you don't know anyone, then you're kind of in a bad place. But doing your research is a skill. I think that I think a lot of people are quick to jump to write their own before they try out other ones. Right. And open source is really easy. If you find something that you think is cool that doesn't have a README or doesn't have a badge in the tests, or a test badge, or even if you want to like send a pull request that adds a Node ICO badge, I've been doing that a lot. Just so people, when they go to a repo, they can see that it's a Node module instantly. There's some really easy ways you can contribute.
So we need to figure out to popularize a culture to strike a balance between cargo culting and not invented here.
Yeah, because rewriting is definitely worth it, especially when modules are small, because the cost of rewriting something might be 5-10 minutes if it's a really simple module. But for me, open source represents, like I have a module I got made fun of actually for writing called iframe. all it does is construct iframes. People were like, why can't you just write iframe in HTML?
It doesn't compose.
Well, that's one thing, but there's also the problem of iframes are really weird, and there's edge cases, and they have default style sheets and weird cross-browser issues with event loading and knowing when an iframe is loaded or reloading or like all sorts of crazy stuff injecting.
Commercial interruption, there's a really good talk about this by Remy Sharp on last year's JSConf. He goes through everything.
Oh yeah, yes. Iframes are weird, and they should be simple, but sometimes you need to stick like a compatibility or polyfill or whatever layer in there. That's what open source is about. It's like edge cases. Like write a library that people can send pull requests to. And if I was really smart and knew all the edge cases ahead of time, I'd probably just write the iframe code every time, but I'd rather just write a module and publish it. And I tried to communicate that over Twitter to the people that were making fun of me for publishing an iframe module, but I think it was lost on them. But yeah, anyway, I think sometimes it's worth it to write new modules, even if you think it's a silly idea. I think actually my most popular modules are the ones that are only like that long that I thought were so simple that nobody would ever use them, like concat stream. All it does is every time you write data to a node stream, it'll put it into an array, and when it's done, it just concatenates it and gives you the thing. And that's like, it was like that much code at first, but now it works in the browser, now it works with old node and new node, now it works with different data types. It's got better over time, and it's like the most downloaded module that I've made, but I've put the least amount of work into it. So it's weird, like I was like sure there was gonna be a module in NPM that did that, and I couldn't find the one I want, and I made it, and it turned out to be successful. And then the ones that I spend a lot of time on, nobody uses. That's just how it goes.
Right. That was a good long answer. A more specific question on the LEVELDB, level up, level down modules. What's the respective production quality of that? What would you use today? What wouldn't you use? What's like the last resort compatibility thing?
So using it in Node on Google's LEVELDB is pretty well tested. The module itself hasn't changed API in a while, the level down and level up modules. Those are trying to get shipped because there's so many modules on top of them that they don't really want to break them. And Google's LEVELDB, Google maintains it, but they don't actively develop it. So there's bug fixes, there's releases every once in a while. So those are used by many companies in production today. Using it in the browser is more experimental, mostly just because IndexedDB isn't everywhere and WebSQL is kind of hacky. It actually sorts data differently in certain cases, so the full test suite doesn't pass, but it only fails because the order is different on some of the results that you get out. So there's, in the browser is more experimental, but you can use it if you're doing something that you know that your users will have, say, like Chrome on Android, or I guess I heard the next version of Safari on mobile is going to have IndexedDB, so I'm crossing my fingers. Yes. But the coolest part about the ecosystem is all the stuff on top of the modules. And even if you don't want to use LEVELDB in production, I think it's an interesting way of writing database modules. There's also a really good Node School workshop called Level Me Up that teaches you the basics of writing your own queries from scratch using LEVELDB. I think it's, of all the Node School workshops, it's the one that I see people have the most fun on. It has a lot of like head scratchers.
We'll get back to Node School in a second. But going up the LeBron stack, basically, like when he's going up to the dunk. No, wait. What's the general level of stability for that? It's like, do you build your next startup on it and take a big risk, and Yahoo should adopt it for doing big infrastructure things, and all good?
Yes.
Good.
I think that, so for LEVELDB, BROwserify, and NPM is now backed by people who have, they can pay people to do support. Right. And there's a couple companies trying to help the NPM ecosystem out. So that's really good. The stability of all the NPMs out there is getting better every day. And I just the other day pulled down all the tarballs in NPM and it didn't crash. So it's like, things that used to not work a couple years ago are working now. And they're putting it in CDNs, and it's faster installs. You can actually install NPM in Europe now, yes, which is pretty cool. Yes. So that part's pretty good. And the BROwserify part, BROwserify is really well maintained in my opinion now. Substack does this amazing thing where he'll write a module that is too big. It's like too frameworky because it's the naive implementation. And then there'll be like a million pull requests from people that want to add features. And then he'll go through in one day and close them all and say, I have shipped a new version that reduces the API so that now you're forced to take your pull request and turn it into a module. So he can basically, instead of saying this project is bankrupt, I'm not going to maintain it anymore, he just reduces the scope of the project so that you're forced to extend it. And so Browserify has become this really beautiful, instead of one big thing, it's a bunch of small things. That Browserify, the API is really small. So I feel really good about the stability there. And we talked about LevelDB before. I think that that's, whereas I wouldn't recommend doing like the MySQL version in production of LevelDB. You can't, it's a very popular choice for things like analytics, or there's cases where to scale LevelDB it becomes more complicated, but for basic apps, I really like the idea that you npm install your database, and now your node process is your server, your database server and your web server, which violates the like 9-factor or whatever that is called.
Yeah, screw that.
Yes, screw that. They didn't think about LevelDB when they designed that thing.
Right.
So it's really, I think it's a really fun database to get started with. You always switch to something more complex later.
Right. Cool. Getting back to Node School, I hear you're running one here.
Yeah, tomorrow. There might be seats left.
I think there are. Tell us all about it.
So if you want to come and learn either the LeBron stack, there's like 9 workshops in Node School that we have, and they're basically designed for people with a little bit of programming experience. We're working on an intro to JavaScript one, but they're all on the command line, and they teach you the basics of things like Node, streaming data with Node, using LevelDB, using binary data with Node, the stuff like not necessarily serving HTML with Node, which is a very popular use case, but it's not what Node is necessarily uniquely best at. We try to get you hands-on with what Node is really good at to show you the wide spectrum of possibilities and not just the same form validation, file upload kind of stuff. Yeah. And there's also, but if you are really interested in web frameworks, there's like an Express one, Express workshop as well. Right. The LevelDB workshop is really fun, and then there's also the Get It workshop. So if you have friends that want to get into Node, or if you yourself want to download Substack's Brain into your brain, then you should come by. It's like $10 US equivalently. I forget what that is in Norwegian kroner, but it's pretty cheap.
Where do people need to go?
They need to go to webrebels.org/tour.
Tour.
Yeah.
Okay.
And it's tomorrow. I don't remember the name of the venue. Tour is in a tour bus.
Tour bus. Okay, TOUR.
Yeah.
All right.
Not
so
as in the
so today is in Oslo, but you're going on tour.
Tomorrow's Oslo, and then also there's Trondheim and Bergen over the next few days.
Oh.
Within the next 7 days, all 3 of those will happen.
All right. Thank you very much.
Yep.